We're going to take a look at what happens now when you mess with the coefficient inside the trigonometric argument. So instead of just taking the cosine of 1 theta, we're going to take the cosine of 3 theta this time. So what we've been seeing is picking values of theta of 0 and pi over 2 and pi, etc. But that's because those are values that are easy to take the cosine of. Okay, and they're the places where the cosine switches from positive to 0 to negative, etc. So we really don't want to set theta equal to those values. We want to set 3 theta equal to those values because 3 theta is what we're taking the cosine of. Okay, so if we take those same values of 0 and pi over 2 and pi and 3 pi over 2 and 2 pi, as our values for 3 theta, then that's going to make it very easy to figure out what r is, because we're just going to take 2 times the cosine of 0, which is 2. 2 times the cosine of pi over 2, that's 0. 2 times the cosine of pi is negative 2, and it's just bouncing back and forth, right? But what's happening to theta is actually that we haven't gone all the way to 2 pi yet. We've gone from 0 to pi over 6 to pi over 3 to pi over 2 to 2 pi over 3, right? To get from 3 theta to theta, we have to divide our theta value, our 3 theta value by 3. Okay, so we see that we're going to start at a maximum of 2 when theta equals 0. We're going to get all the way to 0 by the time theta gets to pi over 6. So let's zoom in on this and let's make sure that we understand what's going on here. We don't want to do something like this. That's no good, because this line, pi over 6, is the theta value that r is going to reach 0. Okay, so all of this part of the curve up here, that's no good, because that's past pi over 6. So we want to make sure we get to 0 by the time theta gets to pi over 6. Just want to erase. Well, that's fun. There we go. So that's going to be kind of like a boundary line. So we'll start at the maximum of 2, we'll go down to 0, and it's going to kind of come in tangent to that dotted line. And then what happens? Well, from there, our r value goes down to negative 2. And that's by the time theta gets to pi over 3. So pi over 3 is right here, but if it's negative 2 for our r value, then we're going to go, pi over 3 is going to be right here. So that's going to be, go away, negative 2. So we're going to come into the same way like that. And then we do the same thing again. We go back to 0. By the time we get back to an r value of 0, that's when we get to a theta value of pi over 2. So we're going to finish up our quadrant 1 angles like that. And then you might recall that what's going to happen is we're just going to keep on circling around and around. So we've created half of a petal over here and 1 full petal over here. And then as we come out of the negatives and back into the positives, our theta values are going to go into quadrant 2. Oh, we actually already have that right here. 2 pi over 3 is an r value of 2. So we're going to continue on like that. I forgot about that piece. So something like that. So we've gone from a theta value of 0 to 2 pi over 3, and we've gotten this much of the graph done. Maybe we can kind of continue this on with 5 pi over 2 and 3 pi. That's going to give us 5 pi over 6 and pi. That's going to also continue this pattern as well, right? So we're going to go back to 0, an r value of 0, when theta gets to 5 pi over 6. So 5 pi over 6 is going to be another guideline right here. So as r decreases down to 0, we want to make sure we don't cross that line. And then we go back to, well, it's negative 2 comma pi, which is going to actually take us back to where we started. So we get ourselves that 3-petaled rose. So we've got kind of these radial lines right here that kind of act as our boundaries. That's not the right one. And those are the theta values that cause r to equal 0. So that's going to be something we're going to learn a little bit later on. But for now, it's just going to help us with our graphing. All right, so as we noticed here, we go from 0 to pi, and we've completed our path. And then if we go from pi to 2 pi, we're just going to follow that same path a second time. So theta goes from 0 to pi to create one full path here. Again, it's very important to recognize the theta values that are used to create the graph as we get into the calculus of this. All right, so when we had a 3 here, we got 3 petals. So if you put a 2 here, maybe you get 2 petals. Of course, we know that that's not true because we remember this from pre-calculus that this is not going to give us 2 petals, but how many does it give us? Well, if we're not sure, let's make that extended t-chart. We've got, again, the values we like to take the sine of are 0 and pi over 2 and pi and 3 pi over 2 and 2 pi. That's going to give us, for the sine, 0 and then the maximum and then back to 0 and then the minimum and then back to 0. But that's not for theta values. Those are for 2 theta values. So divide everything by 2 and we'll get 0, pi over 4, pi over 2, 3 pi over 4, and pi over 2. Nope, just pi. 2 pi, 1 pi. Here we go. So when we graph those points, we start at the pole, we go out to a maximum of 4, and then back to the pole. And that's as theta goes from 0 to pi over 2. So from 0 to pi over 4, back down to pi over 2. So we're going to kind of come out like this, and then go back in like that. All right, well then what happens? Well, then we keep on going with our pattern here. We'll go to 5 pi over 4 and 3 pi over 2. And then 7 pi over 4. And then 2 pi. Oh, the reason I was pausing is like, I haven't done this part yet, have I? All right, so let me graph that as well. So we've gone from 0 to pi over 2, we've done this petal, and then we go from pi over 2 to pi, we go from an r value of 0 to an r value of -4, right? So instead of going through quadrant 2, our negative r values are going to take us into quadrant 4. Yeah, right there. So we'll kind of come out to -4 and then back in again. Okay. And then we'll see, okay, well, we've done from 0 to pi, we haven't completed our cycle yet, right? Because now, as we keep on going, we're going to look at quadrant 3 angles. Our r values are positive, so we're going to go through quadrant 3. And then when we go through quadrant 4 angles, our r values are negative again. So that means that we're actually going to go into quadrant 2. And when we have, whoa, that was kind of funny looking. Close enough. When we have 2 here, 2 is even, means double that to get that many petals. So if the coefficient is odd, then the coefficient is the number of petals. That was 3 up here. If the coefficient is even, you double it. Not only that, but more significantly for our purposes, we notice that we need to take theta all the way from 0 to 2 pi in order to complete the cycle. So theta goes from 0 to 2 pi to create the entire graph.